Want to switch out your RV fridge for a residential one? Let's talk about that. Out here with Around the Sun We Go, and for the past 4 years, my wife and I have been living full-time on the road in our 2020 Grand Design 397TH. Our rig came stock with a Norcold 2118 Polar Max, which is an awesome 18 cubic foot RV fridge. It has plenty of room for us as a couple, and it's also a gas absorption fridge, which means it has the ability to run on either electric or propane and switch between the two automatically, which is really useful for conserving power while dry camping out in the middle of nowhere and for keeping things cold during a power outage. But after about 3 years, we noticed that our milk was starting to spoil sooner than the expiration date, and so I began to monitor the temps and noticed they were getting a bit too high during the hottest hours of the day. So I started with the standard troubleshooting steps. I checked the seals around the door to make sure there were no air leaks, and all was good there. I also checked the interior fan, and it was blowing as it should. The exterior fans also seemed to be working as they should, sucking air in at the bottom vent and blowing it up past the fins and out through the top vent. But just in case the fans are running slower than they used to, I tried boosting the airflow with a powerful desk fan, but that made no difference either. It also been a while since I defrosted the freezer, so I tried that, but still no improvement. I tried running on electric only, I tried running on propane only, no difference. Day by day, the temps were slowly creeping higher and higher. As I investigated deeper, I discovered this yellowish green substance inside the burn tube. It turns out our cooling unit had sprung an ammonia leak, so I shut it off immediately. This also meant it was completely toast and unable to be repaired. So we only had a few options. A new absorption fridge just like this one was over $5,000, so that was a no-go. We could simply swap out the cooling unit for a new and improved one from JC Refrigeration for about $1,900 shipped plus my labor to install it, and then we'd have exactly what we had before, but just a bit more robust. We could also convert the system to only run off a 12-volt DC battery power, which is much more energy efficient, for around $1,700 shipped, or we could convert it to run off of 120-volt AC power, like a standard residential fridge, for around $1,600 shipped. Or finally, I could buy an entire brand new Samsung residential fridge for around $1,500 shipped, which is what Grand Design is putting in all their new RVs these days anyway. So we decided to upgrade to a brand new Samsung unit. You can see the full model number we chose here, but I'll also list it in the description below. It's a counter depth smart fridge with French doors and no exterior handles. It comes in 3 finishes, and we chose stainless steel. So how do we make this swap work? The first step was to remove the original unit. To do that, I popped the trim off at the top and the bottom, and then removed the mounting screws. I then chose to remove the doors because 1, I wanted to protect them from damage so we could resell them. 2, I wanted to remove as much weight as possible to make it easier for my wife and I to carry the fridge alone. And 3, to make it that much easier to grab and fit around our countertops and through doorways. To remove the doors, I popped off this cover to access these bolts, got a firm grip on the door, and then removed the bolts and bracket. This is the same for all 4 doors. I then went outside to turn off the propane tank so I could bleed pressure from the system using the stove. I just kept igniting the burners over and over until no propane was left. I was then able to safely disconnect the fridge propane line from this T-fitting and use a cap to permanently block off this opening. Once tight, I opened the propane tanks back up to repressurize the system and then used some soapy water to check for leaks. I then removed the 4 visible mounting screws from the floor. I removed the screw from this bump mount and carefully pried and rotated it away so I could access and remove the 5th mounting screw. I also eventually removed this bump mount altogether. I then unplugged the AC cord from the wall and tucked it away. Then I disconnected and taped off the 2 positive and 2 negative 12-volt DC wires that are attached to the RV. One set is live and coming from the battery, and the other set goes to the stove. These will be reconnected later. Now that everything was unplugged, it was free to slide out. We then slid the fridge forward enough until we had access to these 2 front straps. We then laid a thick moving blanket on the floor and used the 2 front straps to pull the fridge out enough for us to get a grip on the 2 rear straps. We then lifted and lowered the fridge onto the moving blanket, making sure no metal was touching our vinyl floors. We were then able to carefully slide the unit across the floor with ease and rotate it around and in between our center island and kitchen counters. I then wanted to remove the heavy and leaking cooling unit before my wife and I tried to move the fridge through any doorways. I started by removing all of the bolts from the back wall of the freezer compartment. I then removed all the bolts from the fins on the back wall of the fridge compartment. I then moved to the back of the fridge. There were tons of bolts, screws, and wires that needed to be disconnected. I also had to cut the silver insulation tape with a blade and ultimately peel the unit away from the back of the box. Once removed, it was fairly heavy, but easy to get out of the door myself. This is the unit that would have been replaced if we decided to go the JC refrigeration route. Once that unit was off, It was easy for my wife and I to carry the stripped down box outside with the 4 included straps. Since the cooling unit was basically trash, I decided to pop it back onto the empty box using just the main mounting bolts, and then Lowe's, who delivered our new fridge, took it all off our hands for free. I also kept all the doors and extra parts to resell on eBay, where I ended up making back $1,000. So all things considered, our net cost for this repair/upgrade was only around $500 total. So with the fridge out of the way, I then got to work sealing the 2 exterior vents, which at this point were wide open to the outside world. I first removed this airflow board, which we no longer needed. I then measured the dimensions of each vent and cut out 2 matching pieces of foam insulation board. I covered the vents and then used Gorilla Tape to seal the boards to the wall. I then removed the plastic vent covers from outside and sealed them up with Gorilla Tape as well. Since we no longer needed any external airflow for the residential fridge, the foam boards and tape are meant to keep the bugs, humidity, and temperatures out. Here are the 12-volt wires I disconnected when removing the fridge. These go to the stove and these go to the battery, so I simply rejoined the positive to the positive and the negative to the negative, restoring the stove's DC power. I then removed all of this insulation because I wanted plenty of space around the residential fridge so it has plenty of airflow and room to breathe. I also removed this other unneeded airflow plate so I could finish sealing off the top insulation board. And then here you can see the final product. The DC wires for the stove are routed cleanly on the back wall out of the way, and the outside vents are totally sealed off. Next was installing the new fridge. The delivery guys offered to bring the new unit all the way into the rig for us, which I didn't expect, but it was super helpful. I had them roll it up our rear ramp door and then carry the unit through our wider garage door, which meant they didn't even have to remove the fridge doors, even though I was keeping that drill ready. We used a moving blanket to slide this fridge as well. It wouldn't fit around the turn at our island, so I did have to eventually remove the doors myself. Then, since there were no lifting straps on this fridge, in order for my wife and I to evenly lift the unit up high enough to slide into the opening, we used leveling blocks under the front wheels to increase the height while supporting its full weight. I'd lift the front wheels off the ground, she'd load the blocks, then I'd rest the front wheels on the blocks and lift the rear ones off the ground to see if we were high enough. If not, I'd pivot back to the rear wheels, she'd add another block, and so on until the rear wheels cleared the platform. We were then able to push it in and let it rest. So lifting a 200-pound fridge almost a foot in the air and then backing it into a narrow opening ended up being no problem at all. But then we ran into a different obstacle. Although the hard height measurement of the fridge easily fits inside the dimensions of our opening, when you add in the plastic door hinge covers towards the front of the unit, we didn't have enough vertical space and I couldn't get the front wheels up onto the platform. So I made a mark and cut off just a few inches from the top. This wood was much harder to cut than I expected, so the cut job was terrible, but I knew it would be covered up later. This additional space allowed the fridge to go in just deep enough for me to get the front wheels up on the platform and then extend the front feet to support a majority of the weight. By the way, the feet come mounted in front of the wheels like this, but I flipped them around to this configuration. Then, for some reason, the fridge was lower in the back than it was in the front, even though all the wheels were flat on the platform. To fix this, I used a blade to cut an access flap in the rear insulation and then rolled the rear wheels up onto some plastic shims. Once the fridge was nice and level, I set up the inside, turned it on, and let it cool for 24 hours to make sure everything was working properly. After hitting super low temps in both the fridge and the freezer, I began to permanently mount the unit to the platform. To do this, I used some spare L brackets I had laying around and attached them to the bottom of the fridge frame by removing a bolt and then running it back through the bracket. I then ran a couple 3-inch deck screws through the bracket and into the base on each side. Again, not the prettiest job, but it's out of sight and holds very tight. I then wanted to mount the back of the fridge to the platform. I used a few more spare L brackets that I had in a similar fashion at the back. I removed any screws that seemed to be mounted to a solid piece of the frame and then ran them back through the brackets and then ran a few wood screws down into the floor. I pushed and pulled on the fridge a few times and everything seemed to be holding pretty well. Then, before sealing everything back up, I wanted to test the fit with the slide out closed. We carefully brought the slide in, ready to stop immediately if it looked like there was going to be contact, but luckily for us, the slide stopped with right at half an inch of clearance between the countertop and the fridge door. Another thing I wanted to note, we previously removed this cabinet door because we like having open access to a trash can under the sink, so it wasn't a problem for us, but if that door was still here, I noticed the door handle would have made slight contact with the freezer door. So in that case, we would have either needed to remove the handle every time we bring the slide in, or swap to a shallower handle that sticks out less. But now that I was totally satisfied with the install, I sealed the exterior flap with Gorilla Tape and closed everything back up. We've been using this setup for over a year now, and everything has held up great. No wind, moisture, or pest penetrations. Next up was to make the installation look professional. Browsing around at Lowe's, I found some lightweight 9-foot long garage door weather strips that were a great color match for our interior, and also had these rubber flaps that I thought were perfect for allowing airflow while also visually covering any excess gaps. So I took a few measurements, cut the pieces to size, and then used a few Velcro command strips to mount it all around the border, making it easy to reposition and move if I ever needed to. The final product looks very clean, and you'd never know the fridge didn't come stock from the factory. And that's the full swap. I also wanted to mention a very important bonus tip that applies to this specific Samsung RF18 model. In my research, I learned there's a common issue with these smart fridges where the computer sometimes glitches and causes the unit to stop cooling intermittently. Simply unplugging the fridge for 30 seconds resets the computer and instantly solves the problem. So nothing is actually broken, but if you don't know this, the issue can quickly become a huge pain. To get around this annoying problem, I simply plugged our fridge into a $5 smart outlet and programmed it to cut off at 7 a.m. and cut back on at 7:01 a.m. every other day so the computer is constantly reset. It's been running like this for over a year now, and we haven't had a single cooling problem. So I hope you guys found this video helpful. Let me know in the comments below. Are you considering a fridge swap, and if so, why? Are you having problems with your RV fridge, or do you simply miss the performance and efficiency of a residential one? And would you go with the Samsung RF18 model or choose something different? Also, feel free to drop any questions you might have in the comments below. I'll do my best to get back with you as soon as I can.